In section 5.3, or part A, we are going to find the roots of quadratic equations by graphing. So the first thing we need to talk about is what the zero of a function is. It's an input value of a function f of x, or function x, that makes the output value y equal to 0. Now the root of an equation is the value of the variable that makes this equation true, ax squared plus bx plus c equals 0. So functions have zeros, or x-intercepts, and equations have roots, or solutions. So off to the side here, if you just kind of want that summarized, if you have f, let me write that back up here, f of x equals x squared plus x plus 1, we would say we want to find the 0. If we have x squared plus x plus 1 equals 0, we would say we want to find the root. So it's just, one's in function notation, one is an equation, and so that's what, for our purposes, what the difference is between 0 and root. All right, now we're going to identify the zeros of a quadratic functions. Zeros are very important. There are a lot of practical applications for zeros. If you start here at 0, 0, and we think of the x-axis as the ground, you could shoot a rocket off. It gets to a certain height, and then it falls back down to the ground again. So we're interested in how long it took for it, when it was shot off, to get back to the ground again. Or kicking a soccer ball, reaches a certain height, comes back down to the ground again. So zeros are where the function has a y-coordinate of 0. So looking over here, if we want to identify the zeros, all we need to do is go to the x-axis, circle the points that are on the x-axis, and identify the x-coordinates, because the y's are always going to be 0. So if you want to think of this as height, the height is 0. So our zeros would be, for this, x equals 2 or x equals 4. All right, now you were given the graph in this problem. Now we're going to make the graph up and then find the zeros. So this is in standard form. That means we need to do x equals negative b over 2a. So x equals, we'll put always write the negative down, and then write the number. So negative 2 over 2 times a, which is negative 1. So that's going to be x equals 2 over negative 2. So x equals negative 1. We're going to put that in the middle. And now we need to find y. So again, we can say this is y. That's how we're going to find y. So we'll say y, let me write it up a little higher here. Y equals negative, and then we're going to put a negative 1 in here, square it, minus 2, negative 1, and then plus 3. Okay, so that's going to give us negative 1, because we square it, we get 1, and then multiply by a negative 1, that's going to be negative 1 here. And then that's going to be plus 2, so that'll be 1, plus 3, which is going to give us 4. Okay, so let's go ahead and graph that. Negative 1, 4. And now we're going to draw the axis of symmetry. And if I'm at negative 1, 4, I want to go 1 unit to the left and then 2 units to the left. So that'll be, if we're at negative 1, we'll want negative 2 and negative 3. And if we go to the right of negative 1, we want 0 and 1. Okay, so I'm going to substitute 0 into here. So that's going to make this equal to 0, that equal to 0. So it's going to be 0, 3. And then I'm going to do the 1, just because I think those will be easier than doing the negative 3 and negative 2. So y is going to equal, we'll line it right up with the 1 here. Y is going to equal, I'm substituting 1, so this is negative, and then it's 1 squared minus 2 times 1 plus 3. So y is going to equal, we square the 1 first and then multiply it by negative 1. So that's negative 1 minus 2 plus 3. So if we have negative 1 minus 2 is negative 3, plus 3 is 0. So at 1, it's going to be 0. Okay, now if I've done my work correctly here, these are symmetric, so 1 unit away on the right is 3, 1 unit on the way on the left is 3. 2 units away from the vertex on the right is 0, so 2 units away on the left is also 0. So let's go ahead and graph those points. We have 1, negative 4, we have 0, 3, and then we have 1, 0. And then on the left, so here we have, oops, that's at 2. We need to go up 1 little bit here. Okay, so we have 1 unit away here. We need to go 1 unit on the other side. We have 2 units away here. We need to go 2 units away over here. And then we can just connect our points. And you have your parabola. So now we need to find the zeros. We go along the x-axis. And that's going to be a 0 at x equals negative 3, or x equals 1. And we can also see it in our table. Whatever the y values are equal to 0, the x values are zeros. Okay, you have 1 to try on the other side.